Good morning, everyone, and thank you very much for being here with us this morning. We will basically hopefully expose you to some of the digital capabilities and the trends that we see in the built environment. Right, we are a global company, an American company. We have about, I think, 70 people in Singapore and I think around 100 in plus in Southeast Asia, but in total we have about 4,500 people across the world, and you know we cover a number of capabilities. I will show you in a moment what do I mean by that. So bear with us. Apologies, I might be coughing a little bit, but hopefully it's going to be clear enough for you. Okay, so just quickly about myself. I'm here you go. I'm a global director for success offerings. We relocated in 2019 to Singapore to run an industry program. I'm a chartered engineer and an architect by background. Slowly moved into the business world. A bit about Bentley, you know, around the world, engineers, architects, and constructors, owners, operators are using our solutions to design, build, operate infrastructure, which we want to be smart and sustainable, right? And if you look at Bentley, most of the transport network, like water, energy networks, or you know, civil infrastructure networks, we use our technology one way or another. And you can see some of the capabilities there or industries that we cover. So let's look at the digitization of the built environment. And I wanted to bring some examples to start with that you are, I think, very familiar with, right? So if you look at some of the examples in Singapore, you know, our software have been leveraged to design the structures of the Science Museum, the structures of the Marina Bay Sands building, but also the geotechnical design for all the embankment below ground. Actually, now I should probably use some more recent example where we have, for instance, work with Singapore Land Authority to create a digital twin through our reality modeling capture of entire Singapore. And you know, what we see is that more and more adoption of augmented reality technology. So imagine infrastructure that you can actually inspect remotely, this is now possible with something that we call the digital twins. We can use reality, you know, using real-time high fidelity rendering to allow multiple parties, civil engineers or contractors to inspect potentially the same asset from different locations, saving up to 40% of the labor time. And we have strategic partnership with Microsoft to co-develop some of the technology there that you can see. But it's also for us assets that you can oversee, right? So it's about ensuring that we built twice. We built the virtual world and the physical world, and we can overlap the two worlds together to monitor the construction as it happens. But it's also about assets that I can interact with, and here we have a few examples how the augmented reality technology again provides you the ability to interact with things, to visualize things, to comment on things, and generally understand each assets much better. But it's also about assets that I can predict in terms of performance. So as you design it, and then you build it, and then you operate it, here again, the partnership with in this particular case with Siemens, and Microsoft, because we have actually this one is Microsoft, because we've worked on the asset digital, on the Microsoft Azure digital twins, where you can actually predict, what type of, how much energy is being consumed or is being generated for the foreseeable future. And it's also about, controlling assets. So we're also in manufacturing, when we're mostly looking at it from the built environment perspective, at the building, for instance, and the structures. So we've worked with many companies in automotive space like Volkswagen, BMW, and pharmaceutical space as well. And so we can understand the needs and the key challenges that are being faced around, how do you pull this information together, visualize it, and make informed decisions. So, if we look at other industries as an example, other industries have been in this space for a bit longer than us. So, for instance, if you look at the digital twins in Formula One's, designers have been simulating the race between the races to prevent accidents, optimize car performance, redesign the parts, and maybe optimize the fuel consumption, right? So what can we learn? What can we learn from this approach? The key outcome here is having cars that are safer, more reliable, better performance. So can we talk about better roads, safer roads, right? Safer rail, more optimized performance for rail and road, or bridges or buildings, right? I think this, how can I say, these outcomes are still pretty much applicable as where, and other industries like aircraft industry, they have been using the digital twinning concept for long enough. And as well, how can we look at simulating, for instance, the engine here, and see, how is it performing, whether we need to do maintenance or redesign some parts or replace some parts. Again, it's quite important. So, what most of us think about the digital is mostly from a technology perspective, right? So we have, yes, the drones, the digital twins. We can see the advent of robotics coming together and providing you this automated way of construction and operations. We see all this different technology coming from various consumer space as well. But ultimately for us, what is really important and should be for you guys as well is what the technology will help you achieve, right? It's not the technology for the technology's sake. It's really about improving certain outcomes like productivity, like performance of a schedule, rework reduction, better coordination, and so forth. The key question is, how do you get from where you are to where you want to be? And you want to address some of those challenges around complexity of a project. If you have a complex infrastructure project where you have road, rail, you have underground assets, utility networks coming together, how can you sort of visualize it, provide this context in the first place, what's already in the ground or overground to reduce clashes. When you design a road, a bridge, a rail, and you want to design it in the context. You never design it in isolation. So how can you make sure that you have a good, understanding, spatial understanding that you can see and almost touch around the digital asset, the assets, physical assets that are already there, right? And once you have that, then you want to also look and ensure that you have an understanding of what does it cost us, right? Like, what are the resources required to build and operate an asset? And you want to ensure that you have full transparency of the data there. The problem that we have seen, though, is that actually, if you look at the construction digitization index, actually construction has been quite low in the digitization space. It's just above agriculture. I think this is from 2016, and I think we've done some advancements since then. This is 6 years ago, 5 years ago. But I don't think it's enough advancement, to be honest, right? So every industry is advancing, and I think we have much more to do, which means you have a lot of opportunity to improve some of these outcomes, right? So as you step in from university into the industry, you can say there's plenty of work to do in terms of how digital can help. And if you look at some of the overspend on some of the infrastructure assets, you can see that most of the, on average, overspend in terms of what you plan to spend and what you're actually spending are quite considerable, right? So in the rail space, we spent about 45% more than what we planned for, and this is a hugely important problem in terms of how do you budget, for how do you run an infrastructure projects. And the technology is there to provide you with, some of the improvements, and these are the targets from the UK around faster delivery, lowering the cost, and of course the emissions as well. And and what we see now is, as you're designing and constructing a piece of, whether it's a road or it's a building, now that we have that information available in various forms, whether it's 4D, 3D, 5D, you can start to see that we can make more informed decisions because we have information at our fingertips that provides us the transparency. And especially if you look at some of the tight locations, so you can see this is a couple of towers in London trying to bring in the materials to site, and someone needed in the first place to design the road, the access road, to design those buildings. These are the engineers that have done that, right? And then this information, whether it's graphical or documents, needs to be brought together to be able to better, collaboratively come together and plan. How do you install these assets, right? How do you bring the mechanical equipment into these tight spaces? What's the progression? What's the sequence? Who's doing it? How much does it cost it, right? But this is only possible if you have a proper 3D and documental and other non-graphical information in the first place to get there, right? And here are some of the other sort of capabilities where we see some of the research that is going around, monitoring, continuous monitoring of site through the web cameras, where you can start to recognize the assets, what they're doing, their activity. And here's just another example, monitoring of what's happening, prevent accidents, to ensure a safer site. And finally, as you bring this information, it's not just about the graphical information, it's also about this non-graphic information that is presented in a unified form, whether it's looking at the cost, what type of assets are in there. As you have a beam or a piece of road, how lengthy is it? How much concrete do I need to build these assets? And therefore, do some scenarios around, what we planned for, what we actually updated the schedule as we're installing and constructing, and maybe look at, what's the impact if there is some delay on site. And if we want to spot the difference, right? I sort of show it quite often in terms of what's happening on site in the construction industry, where you have paper-based workflows, and what's happening in other industries like logistics. Take examples, Amazon, or you can have Lazada or other sort of e-commerce platforms, how they structure information, how they handle all the physical goods, and the question is, do you want to be seeing a site that's misorganized and messy, or do you want to see the site that's really automated and every object is really clearly well defined, and therefore we can manage the installation, be always on time and on budget. So I don't want to go too much into detail here, but for me, this is a conceptual exercise on how do we ensure that from the operations, once, let's say, after you install an asset, and let's say you have typically most of the roads, most of the assets already exist, right? 99% of assets of infrastructure already exist. So you never really start from scratch, right? So the question that you want to ask yourself at the beginning is this existing infrastructure fulfilling the needs? Is it too costly to maintain? Do we need to do something about it, right? And then you sort of start to plan in terms of a strategy. What outcomes do you want to get for society, for the owners? So, for instance, you want to have maybe reduced time to travel from Changi to perhaps the West Coast, right? And then you want to see, okay, how do it takes us 2 hours or 1 hour or whatever, right? And maybe you want to reduce it to minutes, right? And this is the way that all these major connections have been planned for, to be able to identify what are we actually trying to achieve with actually building a new infrastructure assets. We then brief the team, we conceptualize the solution, we design the solution, we build it, and we hand over to the owner, right? So I want you to keep in mind this full life cycle of planning, and even what do we do when there is a disaster, and how does it work in terms of building the creating identifying the outcome, looking at the functional specification on what the road or rail or a building needs to do, building these digital assets, right, in the first place, which would be your BIM models, your all your schedules and information, and then finally building the physical assets based on that information. Right, and I'm not going to go too much into the detail, but what I'm trying to say is that we need to start to think about something that we call TOTEX, which is the total expenditure across the asset life cycle, including the environmental impact of the infrastructure that we build. And typically there is most of the focus is on the capital expenditure, is what we expend to design and build an asset. But you can see that actually the cost that is associated with designing and building an asset is much smaller if you look in comparison with the costs of operations. But the decisions that we make in design and construction have a great impact of what does it cost to operate and maintain, right? So you as an engineer designing a road, a rail, or building, you need to keep in mind the operations as well, and the environmental impact, which ultimately has a cost on that asset. So for me, it's really about knowing where you are, knowing where is your how much road how long is the road, right? How much concrete do we need to pour? How much do we already pour? How much more do we need to build, right? So everybody is on the same page in terms of the construction schedule, knowing where we want to go, what's the plan, and get there faster through automation, ensuring that we have more quality content in there. So, but again, for me, it's really about finding the answers, right? And finding the answers starts with knowing the questions, right? So, for me, the information models whether digital twins, BIM models, or whatever it is really the answer to a particular question. But the question is, do we know the right question, right? So what do I mean by that? Well, if you look at the, here's a tunnel, a bridge, a road, the questions could be things like, when is the element going to be installed? Who is going to install it, right? How do I install this element? What are the risks, and so forth, right? And then we can provide the answer, right? Then we can build the model. We can start to use the AR or to explore those information and perhaps flag issues, risks, inefficiencies, clashes in terms of a design, clashes in terms of a schedule, and we can have a very programmatic and transparent approach to design, construction, and finally operations. And once we build this asset, there's and for you engineers, a lot of opportunity there, because as I told, as I said before, 99% of the infrastructure is existing already, right? So a lot of the work that you might end up doing is not designing new infrastructure, but is actually working with, building the information models for the existing infrastructure. We have technology that helps you recognize the assets, and then also recognize perhaps the state, maybe there is corrosion, maybe there is some cracks in the existing infrastructure, so we can maintain it better. And talking about the asset recognition, we now start to use AI to recognize the objects, and these are, what you see here are 3D models made out of photographs. Maybe let's say there is 100 photos, maybe 200 photos, or sometimes 1,000 photos are being made. And our technology can assemble all these photographs, build a 3D model out of it, and recognize the assets, right? So we can recognize that this is a pump, that this is a gauge, that this is a valve, right? And so forth. We're building an asset recognition capability to do that. But the key idea is that as you're building all these different assets, all this different information, how do you ensure that it can be brought together and consumed by everyone of the team? If you think about a typical project team, it's sometimes thousands of people are working on it, hundreds of companies, right? Whether it's a designer, whether it's all the builders, subcontractors, people that pour concrete, people that that install the steel, and all the supply chain that's involved. Now, how do you ensure that there is good visibility of that information? So for us, we've at Bentley, we made quite an important decision a few years back in ensuring that we release our key technology as open source. So you can now take our technology, our iTwin technology that we called, and you can build the applications on top of it. You can take the source code from GitHub and build your new use cases and technology on top of it, right? And to do that, we need to have a federated and open approach where we're bringing the IoT data, which is the Internet of Things, the engineering data like 3D models, CAD data, non-graphical data, all the surveys, right? Underground, overground, to make this a useful digital asset. And the way that I sort of break this down, I understand this might be a bit conceptual, but I would like to ask you to think about this as a model where you all you want to do is to make informed decisions, right? So you want to have better outcomes, let's say, less costly, more efficient, better performing infrastructure. And to do these decisions, you want to make sure that you have decision-making capability and you can analyze the information. But you can see there is a big divide from just producing the models and information, whether it's B models or any type of data, and to get to the decision making. So we bridge this gap with building something we call the digital twin, and we have also the information management capability, which is basically like, imagine your Dropbox on steroids, right? Everybody uses Dropbox or maybe Google Drive or something like that, to store information. So in our world, we have an advanced capability to manage, distribute, verify, validate, quality assure information, which you call information management. And we have a number of technologies to do that. So this will help us really with, having a transparent, trustworthy data, and finally improve construction management capability. There is one last concept that I wanted to leave you with. It's about change. So when you are trying to implement new capability on your projects, in your teams, you will see that about 70% of change efforts fail. So it's not really about the technology, pure technology implementation. A lot of it is about creating the process, right? Building a vision that everybody can subscribe to, and then enable the people to actually, adopt the new processes and workflows. And the problem typically manifests itself when, for instance, if you look at the road, typical, let's say, infrastructure project, you have a client which might have a certain target outcomes in mind, perhaps on-time delivery or on budget. You will see that there is a big divide between the supply chain, so people who manage the delivery and people who does the delivery, right? Whether these are engineering firms. So the key idea, there is a big misalignment there, and we often work with the companies to create a success plan, which is like a strategy for execution, and then onboarding the key stakeholders on this journey.